Simplify the following fractions. And then we have 5 fractions that we need to simplify. Simplifying fractions is very important. It's something that comes up pretty often. Anytime we're doing arithmetic with fractions, we usually want to simplify them so that the calculations are as easy as possible, so that we can make sure that we're in agreement about what our answers are. And then if we need to do further steps later, it's always easier to do math with smaller numbers than larger numbers. So we want to get some good practice here. Let's start with 24 over 180. Now, there are different ways to reduce fractions. You can try to find the biggest factor that the top and bottom have in common, but that can be challenging. And so I really like to just find any factor that the top and bottom have in common and then reduce by that quantity. So here, 24 and 180 are both even. So we can take the top and bottom and divide them both by 2. 24 divided by 2 is 12. 180 divided by 2 is 90. So we have 12 over 90. Now at this point, I recognize that both of these are even again. So I'm going to divide by 2. And when I do that, that gives me 6 over 45. And finally, these are both divisible by 3. So I'm going to divide the top and bottom by 3. And that gives me 2 on the top. And then 45 divided by 3 is 15. So we end up with 2/15. Some of you might have divided by a larger number at first. Some of you may have recognized, for example, that 24 and 180 are both divisible by 4, or 6, or even 12. In fact, we could have started off by dividing the top and bottom by 12. 24 divided by 12 is 2, and 180 divided by 12 is 15. So you can do it in fewer steps when you recognize larger factors, but if you have a difficult time recognizing larger factors, it's fine to go one step at a time and reduce by smaller factors. Let's look at the next one, 75 over 120. Now I can immediately see that both of these are divisible by 5 because they both end in 5 or 0. So I'm going to divide the top and bottom by 5. 75 divided by 5 is 15. I did that in my head. If you can't do that in your head, or you'd rather write it out, you're always welcome to do that. That's fine. I go through these videos a little bit more quickly, just because we don't want the videos to be way too long, but you're always welcome to go through and do some of these arithmetic steps on your own. 120 divided by 5 is 24. And then at this point, we can see they're both divisible by 3. So we can divide the top and bottom by 3. 15 divided by 3 is 5. 24 divided by 3 is 8. And we end up with 5/8. Good. Let's look at 12/64. And at this point, I'm actually going to stop writing the numbers that I'm dividing by. I'll say them, but I usually don't actually write that down. When we get good enough at reducing fractions, we usually just do it in our heads, to be honest. So let's look at 12 over 64. Those are both even, so we can divide them by 2. 12 divided by 2 is 6. 64 divided by 2 is 32. And then these are both even again, so we can reduce by 2. When we do that, we're left with 3 on the top, 16 on the bottom. They don't have anything more in common, so we're left with 3/16. Nice. All right, we've got 2 more. 17 over 85. 17 is prime. It's only divisible by 1 and itself, 17. So with 85, we really only need to see if it's divisible by 17, because reducing by 1 doesn't really help. So if you take 85 and divide by 17, well, 85 is about 100, 17 is about 20, and 100 divided by 20 is 5, so we could try 5. 7 times 5 is 35, carry the 3. 5 times 1 is 5, plus 3 is 8. There we go. So 85 is 17 times 5. So if we reduce the top and bottom by 17, we end up with 1 on the top and 5 on the bottom. So 1/5. All right. We got one last one, 500 over 15,000. These are big numbers, but don't let them scare you. We have a trick. When we have numbers that end in zeros, we can effectively cancel out zeros at the end if we cancel the same number of zeros in the numerator and denominator. And I'll explain why in just a minute. But here, the top and bottom both have 2 zeros. The bottom actually has 3, but 2 zeros is what they have in common. I'm going to cross them out, and then that leaves us with 5 over 150. What we did there effectively was divide by 100. If we divide by 10, that gets rid of 1 zero. If you divide by 100, it gets rid of 2 zeros. If you divide by 1,000, it gets rid of 3 zeros. So crossing out the zeros is just a quick and dirty way to reduce by a factor of 10 or 100 or 1,000. So doing that gives us 5 over 150. These are both divisible by 5, so we can reduce by 5. 5 divided by 5 is 1. 150 divided by 5 is, I think, 30. Yep. And then that is our final answer, 1/30.